Hey team, welcome to Science Side Up. I'm Maddie, and today we're going to do something a little different. We are going to take a tour of the far side of the moon. Mysterious as the dark side of the moon. This is the moon, right? This is the part of the moon that we know and love, that we see every night. Now, I am pretty darn sure that the images used to make this globe here, we've got a whole movable globe, I'm pretty sure those come from LROC, which is the Lunar Reconnaissance Orbiter camera. It's one of the many instruments that's on the Lunar Reconnaissance Orbiter, which was launched in 2009 by NASA and is still orbiting the moon, doing its thing. So what I have here is I downloaded Google Earth. So you can download Google Earth, and when you do that, it actually has more features than if you're just playing with it online. And one of the great features it has when you download it is that you can go to the moon and Mars and explore those in the same way you can like the globe Earth. So that is what we're gonna do. So I actually completely love the moon. When I was an undergrad, I got to work on one of those instruments that's on the Lunar Reconnaissance Orbiter. So let me show you what I got to play with as like a 19-year-old kid. We're gonna add the colorized terrain. So this is a topographic map that was made by LOLA, which is the Lunar Orbital Laser Altimeter. So the way it works is it shoots lasers down at the moon and measures how long it takes for that signal to bounce back. And how long that takes is directly related to how high the topography is. So you do that billions of times and you piece it all together and you get a topographic map, which is so cool. And I am so lucky to have gotten to play with this and help in some very small way, making this topographic data available to you all. And that's one of the great things about NASA data is that once they make a product, it is free and available to the public. That's how Google was able to make this mosaic, right? That's really cool, but you could just go get it yourself. Yeah, okay, so a little bit about the moon. Let's take off the terrain for now. No, off. Okay. The moon has what we call a bimodal topography, and that doesn't mean anything particularly fancy. The Earth also has a bimodal topography, right? We have land continents, and then we have the ocean. So there are two main types of terrain on Earth, therefore we have a bimodal topography. So the same is actually true for the moon. It has these dark areas, which are low-lying and flat, and then these areas over here that show up as bright. So the low-lying areas are called the mare. Galileo named them. Mare is Latin for sea, so he thought that these dark areas were actually oceans. So this is Mare Imbrium, which is actually my favorite. That means sea of showers. This is Mare Serenitatis, the sea of serenity. For all those brown coats out there, that's probably your favorite. Here is the sea of tranquility, Mare Tranquillitatis. And if we bring back that terrain for a minute, so notice that these areas are relatively flat. They don't have a lot of craters and they're low-lying. If we compare that to, say, this region over here, I'll take that off. These are those brighter regions. Those are called the highlands. And also the geology of those regions are different. So the mare are predominantly made up of basalts, that's the type of rock you get from think like a volcanic island like Hawaii. They're going to be predominantly made up of basalts. The highlands are predominantly made up of a different type of rock, which is called an anorthosite. Yeah. So for the part we have all been waiting for, let's go take a look at the far side of the moon. I'm going to do this slowly to build tension. So going past all of our mare, and here it is. Here is the far side of the moon. Now in this image, it looks a little boring, but let's bring back up the colorized terrain. Look at that. Look how gorgeous that is. So notice that the topography is much higher on the far side of the moon than it was on the side that faces us. Also, we don't have like any of those lying regions except maybe like here. So it's much more heavily cratered. We don't have those smooth low-lying surfaces. So it's actually very different topologically than the near side. So something that's actually really cool is that we also know that the far side of the moon has to be older. So geologically, those rocks, this part here is older than the part that faces us. So how do I know that? That is a great question. So I want you to look here. Here is our Sea of Serenity. Do you see how there are, let's zoom in. There are almost no craters. So there are very few craters here. Oh, if you're wondering about these little flags, one of the cool things about Google Earth is that it will mark everywhere there's something man-made on the moon. So for example, this little guy, that is where Apollo 15 was. So that's pretty cool. Okay. So very flat, not many craters. Now let's zoom back out and go over. Ooh, zooming. Going over to the far side. Look at how many craters there are, right? That is just, we would say that this surface is saturated. So we can use number of craters to tell which surface is older. So it's kind of a simple idea. The idea is that with everything else being equal, if one surface has lots of craters and another surface has not lots of craters, then the surface with lots of craters is probably older than the surface with not a lot of craters, right? More time has passed, so there's been more chances for stuff to hit it. This is a form of relative dating, so it doesn't tell us how old the far side of the moon is, how old these rocks are, but it does tell us that this part of the moon is older than the other part of the moon. Now, both of these surfaces are going to be older than the crust of the Earth. This doesn't have to do with like when the moon formed or when the Earth formed, but the Earth's crust recycles itself because we have plate tectonics. So the actual dirt we're walking on isn't really as old as the Earth itself. So same thing with the moon. The moon formed at the same time the Earth did 4.5 billion years ago. But the moon doesn't have plate tectonics, so its surface just sits there and gets hit by things. So what we think is going on with the mare, and by we, I mean like scientists. Hold on, let me get you back to the mare. What we think is going on with the mare is that there was some huge impact event that sort of wiped out the surface. And so think of it as like taking an eraser to the chalkboard, right? Some really big event happened, erased all of the craters on the surface, and now you have a relatively young surface. Anyway, okay, so that is the moon. I think we'll stop this part here. Yeah. Okay, guys, that's it for today. Thank you for joining me. I will see you next time. Be sure to like and subscribe. If there's a topic you'd like to see me cover, let me know in the comments, or you can shoot me an email, ScienceSideUp@gmail.com, and I will see you next time.